Assalamualaikum warahmatullahi wabarakatuh. We are students from Group 5B wants to present about the experiment 6 that entitled High Performance Liquid Chromatography, which is HPLC. Now I will introduce my group members that participate in this video presentation. First is Fatin Husna binti Mat Ruzani Nashrun. Second is Nurul Syafiqah binti Abdul Wahab. Third is Nur Aisyah Adibah binti Syamsuddin. And last is Aliana binti H. Apandi. Okay, so now I will explain what is HPLC. HPLC is stand for High Performance Liquid Chromatography that utilize a liquid mobile phase in order to separate the components of a mixture. It's run by analytes that are first dissolved in a solvent, then it are being forced through a column under high pressure. Next, HPLC is very versatile due to its ability to easily separate a variety of chemical mixtures, which include non-volatile and thermally unstable compounds. For example, organic and inorganic compounds, natural polymer, biological sample, and others. Okay, now I will explain the advantages of HPLC. So first, HPLC has greater sensitivity because there are many various types of detectors of HPLC. Next, it contains reusable column that can be used for many analyses after flushing. Third, it is ideal for ionic species and large molecules. Last but not least, sample recovery can be done through fraction collectors. Application of HPLC. HPLC can be applied by many compounds with solubility in a liquid, which can be used as a mobile phase. So first is analytical or preparative can be used in highly purified compound in a small or large quantities. Second, the applications of HPLC are include analysis of sugars, pesticides residues, organic acids, lipid, amino acids, toxins, and vitamins.
Let's proceed to the next part, procedure of this experiment. For part A, experimental. First, we will make caffeine standard solution, which are solution A and solution B. To prepare stock solution or solution A, 10 mg caffeine was weighed into 10 ml volumetric flask. Mixture was dissolved in distilled water. The volume was made up with distilled water. For working solution or solution B, 1 ml of solution A was pipetted into a 10 ml volumetric flask. The volume was made up with distilled water. Step 2. Sample preparation. 10 ml of soft drink sample was poured into a small beaker. A magnetic steamer was used to remove any carbonation. 2 to 5 ml liquid was filtered into 0.45 micrometer pore diameter membrane filter to remove particulate matter. Step 3. 10 microliter solution B was injected into HPLC to establish the retention time of the caffeine. Step 4. Peak area of caffeine was measured. Step 5. 10 microliter of the prepared soft drink sample was injected into the HPLC instrument. Lastly, the peak area corresponding to caffeine was measured by referring to its retention time. For part B, operation of the HPLC. To start the instrument, the system was switched on but not the PC. The on button was switched according to the label hardware number. To run the software, click instrument 1 at class VB. Username and password was filled. Login button was clicked. Pump icon was clicked on and pump window was on. Mode of low pressure gradient was selected. Flow was set up at 0.1 ml per minute. Maximum pressure limit was 2845 psi and the minimum was 0. A is buffer solution, B methanol, C acetonitril, D water. CTO10 AS VB menu was clicked. Oven temperature 28 degrees Celsius and the maximum is 85 degrees Celsius. LCL10 AV was clicked, then trigger type external and power on for event 1 was chosen. Set do not change anything at log menu and go to time program menu. The download, OK, apply was clicked. LC setup assistant icon was selected and PDA image was clicked. The wavelength started with 190 nm and end with 800 nm. Nothing changed in library menu. In purity menu, 190 nm to 800 nm was selected. Channel 1 was selected to DA output menu. Nothing changed in spectrum menu. Appropriate data was inserted in multi-menu and ratio menu 1. The wavelength was set. LC setup assistant was clicked and the pump was on. The proceed with injection. Sample ID data file was filled up and click start. All sample was injected into the port when the maximum volume was 20 ml. A chromatogram shown as result with several peaks depending upon sample. For sample preparation, string was used and sample with 10 to 20 ml was filtered into a vial. The mobile phase was filtered. Membrane filter was used for methanol, water, buffer, and acetonitril. An ultrasonic cleaner was used. Sample injection, single run acquisition was clicked and shrink was inserted and load. Sample was injected and turned down. Select Control and extend run for few minutes. Report, View, Method Custom Report was selected and the results was printed. LC Setup Assistant was clicked for clean-up process. Mobile face B, C, and D was washed with CAN and click 100% ACN. The instrument then switched off.
Let's moving on to the result of the experiment. The retention time and peak area of the result is being recorded as in the table below. As you can see, the result is shown in the slide together with the data of caffeine standard. To achieve the objective of the experiment, amount of caffeine in the sample, the analysis process is continuous by calculate the caffeine concentration by dividing the peak area with the response factor of the caffeine sample. There are some questionnaire and pre-lab questions regarding to our experiment high-performance liquid chromatography. Firstly, define the normal phase of HPLC is use polar stationary and solvent non-polar mobile phase that filled with tiny silica particles. However, for the reverse phase, HPLC is defined as use the non-polar stationary phase and polar mobile phase. Second, define the response factor is the ratio between the concentration of compound being analyzed and a detector's response to the compound. The response from a detector shown as peak by the chromatogram. Next, why the response factor is used to determine the identity and amount of an unknown. This is because, firstly, it is act as correction factor to allow the calculation of the true value of analyzed concentration. It happens when using internal standard calibration. Then, it is also represent the differentiation of response between the analyzed and the internal standard for a particular detector.
Based on the experiment, HLPC component imported to determine the results. The mobile phase in HLPC is in liquid form and experiment soft drink used is Coke. But first, the soft drink need to be degases to avoid shift flow rate during experiment. Injector in this experiment uses glass Hamilton syringe that can stand a pressure of 1500 PS. The column differ in length and porosity depends on compound need to be analyzed. In this experiment, analytical and guard column were used. As for detector, we use UV absorption because medium to large molecule absorb UV radiation. In HLPC, we use reverse phase as it needs non-polar stationary phase and polar mobile phase. The decrease in polarity will increase the retention time, that's why appropriate ratio were used. It will give the desired peaks in a short time. As the polarities illuminated are wide, gradient illusion were used. It helps in reducing time, but at the same time it is too expensive, which the use of the low quality will affect the result. Chromatogram obtained where each peaks were compact for each run.
As a conclusion for this experiment, we are able to determine retention time of standard caffeine solution, which is 0.908 minutes. Besides that, we also has identified the 3 peaks of caffeine in the soft drink, which are 2,082,175 microV per second, next 2,237,029 microV per second, and 2,164,372 microV per second. Last but not least, we also has determined the caffeine that found in the Coke drinks, which is equal to 151.2 ppm. This indicate the concentration caffeine in the Coke drinks. So that's all from us. Thank you for watching.